All right, guys, we go chapter 9. About 4 lessons we're going to be looking at here for chapter 9. The idea for this chapter is transforming our objects. So we are taking things like multiple shapes, triangles, hexagon, trapezoid. We're going to be taking all these shapes, and we're going to see what happens to these guys or how we would move them within a coordinate plane, such as a reflection, could be a rotation, any kind of transformation on these guys we're going to be taking a look at. So this chapter starts with reflecting objects across a line. So we're going to be taking objects like this. So you can see this four-sided shape. We have A, B, C, D. And if we were to reflect it across this line, here's where the image would end up, right? So a couple things about this. One is the line that you are reflecting across is called your line of reflection. So you're going to hear that phrase come up quite a bit. The other thing is the object that you start with versus the object that you end with. So the one that we start with, the original object, we call the pre-image. That's this one right here. So the pre-image is what you start with, and the image is what you end with. So in this case, if we started with A, B, C, D, that would be the pre-image. And the object of reflection would be the image. And one way we can always tell the difference between these is you'll notice on these are just labeled with an A, B, C, D. However, the image, and it's going to be a little hard to see unless you have the printout in front of you, but the image letters have these little accent marks over them, or we call them prime marks, right? So they have this little prime notation that we attach to the image on these. So really important when you guys do these, if you're doing this on a piece of paper or on a graph, whenever you do that, we always want to label the image with these prime marks so that we can tell what was the pre-image and what was the image that we ended with. So as we look at these, one thing that's going to be super important to keep in mind, we'll do a couple practice ones here in just a second, is whenever you reflect across a line, we always want to make sure that we go directly over that line. In other words, we want to be perpendicular to that line. So picture yourself standing here and pretend this line of reflection is a mirror, right? So if you were standing here and you were looking at yourself in a mirror, so here's the mirror, well, you're going to see your image the same distance from the mirror directly across from you, right? You're going to see your image over here, or as you're looking at the mirror, you don't see yourself over here, right? You would always see your image directly across from you. And the other thing to keep in mind is, so the distance you are from the mirror would be the same distance that your image is from the mirror. So if we can kind of count this distance, then I simply would count the same distance on the directly across on the other side to get my image, right? So these guys are going to look something like that. So a couple things we're going to just sort of do for practice here to start is we're just going to do a little drawing, and we'll just do a couple of these guys just so we get the idea. But take a look at the triangle for number one. So as I look at this triangle, if I'm going to reflect this triangle across line M is going to be our line of reflection. Remember, this is called the pre-image. So JKH is the pre-image. Our goal is to come up with the image after it's been reflected across this line that I see right here. Well, one thing to note is if there is any point of this that is on the line of reflection, well, that guy's not going to move, right? Because his distance from the line of reflection is 0. So he's not going anywhere. So point K is not moving, right? I'm going to put K prime in the same location because it's already on the line of reflection, so he can't really go anywhere. However, J and H certainly could. So again, the idea is I want to, as best as I can, I'm going to estimate point J, that distance right there, directly to the line of reflection. Remember, I'm trying to keep a perpendicular line here. Okay, so I'm trying to create a right angle when I view this. So I'm going to go that same distance on the other side and put J prime right there. So let's do the same thing with point H. So I'm going to draw a perpendicular line as best as I can to my line of reflection. So that should be a perpendicular line. I'm going to try to match that same length on the other side. So I'm going to go directly across as best as I can, about the same length. Here is H prime. So those are my 3 image points if I just connect the dots. Then that guy would represent our image, right? And one thing that we're always looking for, and there's a super, super important concept in this, and this is why we are looking at this potentially before chapter 4, is because what we want to see in this is when you transform a figure, whether it's a reflection, maybe you rotate it. We'll be doing that in a later lesson. We're going to do a translation, which is just a shift, right? If I were to take this and slide it across my paper, what we're going to see on that is the image is exactly congruent to the pre-image, right? They are congruent figures. So everything about my image is identical to the pre-image. In other words, here's what they want us to see on this. Within triangles especially, because that's what we're going to be doing in chapter 4, when we do this, all 6 parts still match. In other words, this length is congruent to this length. That didn't change. JK is still the same length as this JK. Those guys are no different. And KH, 1, 2, 3, is no different from this KH. So all 3 sides are still congruent to each other, and all 3 angles are still congruent to each other. I'm going to try throwing a different color into this. So angle H here is still congruent to angle H here. Those angles still match. Angle K is still congruent to angle K. And angle J, I should use double lines for those. And angle J, which I'll use 3 lines for, is still congruent to this angle J. So all 6 corresponding parts still match. They're still congruent to each other. And that's like a major, major idea, because that's what's going to lead us into chapter 4 when we get there. So it's something we're going to kind of keep hitting on as we go through this chapter, is the fact that these items don't change after we do this transformation, right? It's a congruent figure. All 3 sides and all 3 angles are still congruent to each other. Let's just practice on one more here. So let's try it on one that maybe is not touching. Let's go down to number 6 and give this one a shot. So you're always welcome to pause and try this on your own. We're seeing line A as our line of reflection. This is our pre-image. And so our goal is to draw the image. So just pick a point to start with. I'm going to start with W. So I'm going to try to draw, again, I want to see this perpendicular distance to line A. I'm going to match it on the other side. And here is my W. I'm going to try to draw this so it's out of the way. And again, you always want to label that with a little prime mark so we can tell the difference between the pre-image and the image. Let's do the same thing with X. I'm going to try to match that distance on the other side and put it about here. So here is X prime. Let's try the same thing with Z. These guys are a little tricky, especially when they're kind of farther away. So I'm going to try to match that distance directly across on the other side. Here's Z prime. And one last item here. I'm going to try to match the distance for Y directly across. Put me about here. So again, one of the main things that we're looking for on this is, does your image identically match your pre-image? And mine's going to be a little ugly, I can already tell. I'm going to extend my Y value a little bit. But obviously, when we're doing this and making our own drawings, it's not going to be perfect. We're going to get to the perfectness on the other side when we actually put these in a coordinate plane. But for now, the idea is just to help people see how this is going to work as far as the pre-image reflecting over a line to get the image. Right? So it's going to look something like that. If I drew this perfectly, again, all of my corresponding parts would match. So ZW corresponds to this ZW, and they should be the exact same length. They're still congruent. Right? Angle Y corresponds to this angle Y. They would still be congruent, on and on and on, right? All the corresponding parts would still match. So let me take you to kind of the heart of this lesson, which is going to be these guys right here. So now we're looking at figures in a coordinate plane. So this is going to be much more exact as we go through this. The rules that we are given here, I'm going to come back to in just a minute, because those aren't going to kick in until we do the last couple problems. So I'm going to come back to that. So we're going to start out by looking at these exercises right here. And so what I've done is I've already shown the pre-image. Here's FGH, triangle FGH is right here. That's our pre-image. That's what we're starting with. And our goal is to come up with the image after it's been reflected across these lines. So we're going to start out with number 1 here. So my line of reflection is going to be x equals -1. So where do we draw the line for x equals -1? Well, as we've already seen in prior chapters, that would be a vertical line through -1 on the x-axis. So right here, I'm going to draw my line of reflection. So that's our mirror, right? That's what we are going to reflect across. So when we are doing this in a coordinate plane, and our line of reflection is just any random vertical or horizontal line, the best way to approach these is simply to count the distance directly across. A point like G, just like we said on the other page, he's not going anywhere, right? G is going to be G prime because it's on the line of reflection. So anything on the line of reflection is not going to move. All I have to do is count the distance for my other points. So if I look at point F, you guys can see how it's 2 units away from my line of reflection. So all I have to do to get the image is put the image 2 units away on the other side. So F prime is going to go right here. And I'm going to do the same thing with point H. Point H is 1 unit away from the line of reflection. So H prime is going to be 1 unit away on the other side. So there's my H prime. So if I just connect the dots, it's going to look like this. And again, now that we're doing this in a coordinate plane, it should be way more accurate of drawings because we're just simply counting those perfect distances. So now you can see though, and here's the main idea. I'm going to hit on this one more time. There are 6 parts to a triangle, right? It has 3 sides and it has 3 angles. And what we're seeing when we do this transformation is all 6 parts are congruent when we do the transformation. So the 3 angles of this triangle are congruent to the 3 angles of this triangle. The 3 sides of this triangle are congruent to the 3 sides of this triangle, right? They are congruent figures. All 6 corresponding parts are congruent to each other. Let's take a look at what if we were to reflect, and I'm going to go back to this graph right here, the original graph, but now I'm going to reflect it across y equals 1. So now, and this is going to get a little crowded in here, but that's okay. I'm going to draw my line of reflection at y equals 1. So remember, this would now be a horizontal line through 1 on the y-axis. So that guy's going to go right here. And so now I'm simply going to take this black triangle, the one that we started with, and I'm going to reflect it across y equals 1. You'll notice on this one how some parts of it are above that line and some parts of it are below that line. That's okay. That just means it's going to basically flip like this. So what was above it is now going to be below it. What was below it is now going to be above it. So let me try to throw in, if I can, a new color so you can distinguish between what we did on problem 1 versus what we're going to do right now on problem 2. But all I'm going to do is count. Really simple. If we're just using horizontal or vertical lines, all you have to do is count the distance. So if I'm looking at point H was 1, 2, 3 units below that line. So H prime should be 1, 2, 3 units above that line. So my H prime is going to go right here. Point F, 1, 2, 3, 4 units above the line. 1, 2, 3, 4 units below the line should be F prime. And let's do one more with G. So he's going 1, 2, 3 units to get to that line. 1, 2, 3 units below that line. So here is G prime. And so as I connect the dots for my blue triangle, I get this drawing right here. And so there is our reflection across the line of y equals 1. So again, guys, the main thing I'm going to keep hitting on all chapter long is this idea of isometry. So this is your key word here. So isometry, again, simply means that the new triangle is congruent to the original triangle, right? The image is congruent to the pre-image. Nothing about it changed. The angles, all three angles are congruent. All three sides are congruent. That hasn't changed. Let's jump down to this one. So a little more for extra practice. So again, here's a great place to pause and try something on your own. If we were to draw the line x equals 0, so I'm going to draw the line at x equals 0. Again, that should be a vertical line, right? Anytime it's x equals a number, it's a vertical line. So I need to draw a vertical line through 0 on the x-axis. Well, where would that be? Notice that would just be the y-axis. So here's where I want to introduce a rule to you. There are 3 rules that you should be aware of. There's 3 main lines of reflection, right? There's 3 main lines. You can reflect across the y-axis, which is what we're doing on this one, right? Because my line of reflection is the y-axis, as we just drew it. You can reflect across the x-axis, and you can reflect across the line y equals x. Those are the 3 main lines of reflection, and that's where these rules come into play. So these are super important to this, because as you've seen, there's going to be 2 approaches on how we graph, or how we do this process. One approach is simply visual, right? I'm counting. I look at my line of reflection, and I visually count the distance, and then match it on the other side. So it's just a visual approach. I'm not using any rules. I'm not using anything special like that. I'm simply using the visual counting process. And that's one approach. But as you'll see in a minute on the very last one, that can be very tough to do in some cases. So the other method that we can use is kind of your fail-safe here. This method always works, especially if you're not much of a visual person and you learn a little more by wanting to know the rules. This will be more helpful for you. If I reflect any point across, I don't like how it says in the x-axis. I would have said across the x-axis. So if the x-axis is my mirror, right? The x-axis is my line of reflection. In fact, let's just draw it so you have it for your notes. So this is my line of reflection, is the x-axis. So I'm reflecting from there to there. Then the new point is simply going to be the y-coordinate times -1. In other words, and don't worry, we're going to do one like this together. In other words, my original values, we're going to call them A and B, are going to become A, -B. So anytime we want to simply use a rule to reflect a point across the x-axis, all I really have to do is change the sign of my y-coordinate, right? So if this value was positive, it's going to become negative. If it was negative, it would become positive. The A value doesn't change, right? Because as you'll notice on this, all I'm doing is moving up and down, right? So it only affects the y value. The x value is unaffected by this because I'm not going left or right, right? This is a going up or down. What about the y-axis? This is about the one we're about to do here in a second. If I reflect a point across the y-axis, so now we're looking at this. So here's my y-axis, and we're reflecting this way. So you notice on this one, now we're reflecting left and right. So what do you think would be affected? The x-coordinate, right? So if I reflect across the y-axis, now it's my x-coordinate that is changing signs. So what was AB is now becoming -AB. Or you could say the opposite of A, B. Right? I like that word opposite for negative because that implies that if it was positive, it goes to negative. If it was negative, it goes to positive. Right? It's the opposite of A, and then B would not change because now we're reflecting left and right. So only the x coordinate would now be affected. And then one more. So here's the one where I strongly recommend knowing this rule, because this one, as you'll see in a few minutes here, is very hard to just do visually. Okay, so if I'm going to reflect across the line y equals x, and I'm going to go through this and show you the drawing here when we get to the bottom, but I just want you to know the rule for now. And then we'll do an example at the end. So the rule we want to know for y equals x is simply to change coordinate places. So your AB is going to switch places and become BA. Right? They just trade places. No signs change. If it was positive, it will stay positive. If it was negative, it would stay negative. So the rule we want to know for this is simply to trade places with your x and y coordinates. So we'll get to that in a minute. So let's take a look at 3 of these. So I'm not going to do number 4 because it's too similar to what we just did up above. I'm going to do 3, 5, and 6. So as we already looked at on number 3, here's what we got going on. Right? X equals 0 is the y-axis. So essentially on this problem, I am to reflect those 4 points across the y-axis. So there's 2 approaches to this. One would be to do it visually, which is just to count. So if I look at point A, I can say, well, point A is 1, 2, 3 units to the left, so A prime would be 1, 2, 3 units to the right. And that's just a straight up visual approach. I can count it. No problem. But you could apply the rule. As I looked at up above, if I reflect across the y-axis, right, I'm moving this direction. So the rule we looked at up above was that my coordinates are going to become negative A, B, right? The sign of my x coordinate changed places. So look at the original value for A. It was negative 1, 2, 3, 1. So it was negative 3, 1. Well, what did it become? Right? When it went over to the other side, now it became 1, 2, 3, 1. So A prime is 3, 1. So look how the rule fit that description. Right? The sign of my x coordinate changed. And that was it. Negative 3 became positive 3. And that was it. That's how we got the new point. So that would be your other approach. So if I was to look at a point like point D, and maybe I was just given the coordinates. Maybe I don't even have a graph. Right? So maybe I can't take the visual approach if I don't have the graph in front of me. So how do we do this on point D? Well, let's look at the coordinates. It was negative 2, negative 2. So without even looking at the graph, because like I said, maybe it's a case where you don't have a graph. Maybe they're just giving you this, and they're saying, what would D prime be? Where would the image go? Right? So if I just apply the rule says just change the sign of your x coordinate. So what was negative 2 is going to become positive 2. My y coordinate does not change. And there we go. We have the image of D. You can see how that would still fit the graph, though. It was 2 units to the left. Now it's going 2 units to the right. There's D prime. And you'll notice, sure enough, it's at positive 2, negative 2. Right? And so this time we got it by using the rule rather than visual. But we can do either one. Right? We can do either one in these cases. Let me just finish off the drawing for this. So point B was 3 units to the right. So now it's going to go 3 units to the left. Point C was 2 units to the right, and now it's 2 units to the left. So if I connect the dots on my prime points, so again, you can see this perfect reflection, this perfect symmetry across the line of x equals 0, or you could say across the y-axis. Right? So let's move on to the last 2 rules. What about the x-axis? So on these last 2, we're going to start by plotting the points. So let's go DEF. So D was negative 2, negative 1. Again, I want to mark those so we know the original set of points here. So E was negative 1, 3. and point F, 3, -1. So here was the original triangle. Looks like this. So we have our original set of points. If I'm to graph across the x-axis, so I'm going to reflect across the x-axis. So now in this one, the x-axis is my line of symmetry. So that is my mirror, my line of symmetry. And again, you have two approaches. We have the visual approach, which would just be to count. So D is 1 unit below. D prime is going to be 1 unit above. If I look at point E was 3 units above. I'm going to make it 3 units below. So here's E prime. Point F was 1 unit below. Now it's 1 unit above. Here's F prime. So as I look at my new triangle, my image, I get this, again, perfectly congruent triangle to the original triangle, just been reflected across the x-axis. Again, notice that all 6 corresponding parts are congruent, right? The length of DF in the image, or sorry, the pre-image, is congruent to the length of DF in the image, right? I can count those squares and identify that they are still the same length. So again, all 6 corresponding parts would still match. All 3 angles and all 3 sides. So the other thing I wanted to show you on this is I could have used the rule. So we saw up above that a reflection across the x-axis are points moving up and down, right? So what was AB has now become a negative B, right? That's the rule that's been applied here. So let's just look at it with one of the points. D was -2, -1. D prime is what? So D prime is now -2, +1. And again, notice I could have gotten that without looking at the graph just by applying this rule. All I had to do was change the sign of my y coordinate to get my image. And I could do that with all the points. Okay, here's the key one. Graph the line y equals x. Think of this as y equals 1x plus 0, right? We just got done doing y equals mx plus b, right? So if this is 1x plus 0, that means I'm starting at 0, and my slope is 1, or 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. So my line for y equals x is right there. Let's draw that. Stick with my red line of reflection here. So there is the line of y equals x. It was this guy. So let's look at the original points. So point A was 1, 4. So where would A prime go? And this is where it can be a little tricky, because now you would have to try to count diagonally. And that's where people can often make mistakes and have a really hard time doing this visually. You can do it. It can be tough. So like I could try to say, well, I'm going to go 1.5 diagonals. So 1.5 diagonals would put me right here on the other side. So it's not that it's not doable. It just can be very tough visually. Again, especially if you're starting from a point farther away, it can be tricky. So I would suggest applying the rule on this one. And remember, the rule is a simple one. All that happens is my coordinates trade places. Right? So if A was 1, 4, A prime is going to be 4, 1. So it's a super simple rule. And that's why I recommend using it in cases like this. So A is simply going to become 4, 1. And sure enough, you can see 1, 2, 3, 4, 1 is where it ended up. Right? So we can use a rule. I feel it's a safer approach, but we can still really do it either way. This is the one I would recommend. So let's try the same thing with B. If B is at 3, 2, which would be right here, B prime, if I just trade places, would go to 2, 3. So 2, 1, 2, 3, and there's B prime. So again, you could try to do this visually and count diagonally. Whatever works best for you. And let me just finish off the drawing. So C was 2, negative 2. If they trade places, it would become negative 2, 2. So here is C prime. The original C was 2, negative 2. And let's do the same thing with D. Negative 3, 1 is the pre-image. So the image would be 1, negative 3 if they trade places. So let me connect the dots here. So my original A to B to C to D. Looked like this. So we had this like trapezoid kind of a look. I guess it's not really a trapezoid, but similar. Anyway, here's the new image that we came up with. And one of the things I really like by graphing these is, generally you should pretty much be able to tell if you ended up with the perfect reflection across that line, right? If we did this right, I should see an identical picture on left and right. If I were to fold my paper across this line, whatever's on this side of the line should lay right on top of what's on this side of the line, right? If I did that right. So anyway, that is it for our first lesson.